First one on your study guide. It's a word problem. I underlined the first sentence, which I think is super important. It says the rate at which, and you need to know this sentence, these always show up. And it's a really good application of calculus. Anyway, so it says the rate at which water is leaking out of a tank is proportional to the amount of water in the tank at time t. So if I let P, whoops, I'm gonna go to black. If I let P of t equal, what am I talking about? Undo. If I let A of t equal amount of water in the tank, then A prime, what this is saying is the rate, which is dA dt, so that's A prime, equals, is proportional to the amount of water. So is proportional means I can write is A times some constant of proportionality. So this is one that we've solved quite a bit, and you'll definitely see one like this. I can rewrite this as dA dt equals A times K. And I use separation of variables here. I do another example of separation of variables on number 4, I believe. Anyway, so what I can do here is divide by A on both sides and get dA over A equals, and then multiply by dt equals K dt. Now, it's in a form where I can integrate it. So I'm going to integrate the left side with respect to A and the right side with respect to t. What that gives me is I get ln absolute value of A, because that's 1 over A, time is equal to K times t plus c. So from here, I do e to the on both sides because I want to get to what A is. The e to the on the left side, these guys, e to the and ln cancel, give me A out. That's A of t. And I'm going to reorder some things, and if you want like a better explanation of it, you can go watch that other video for number 5. But what I can do is reorder the way I've got my C's, and this, and write it so that I have let this be a C1 equals C times e to the K times t. So, you should be good getting to here. The other thing that you should know, and I'll get rid of... So the other thing that you should know is that this C right here is really the starting amount. And we can see that really easily by... I'm going to work it out and show you how, but you could just jump straight to putting C equal to 400. So what this right here that I arrowed right here says is that A of 0 is equal to 400. So what I can do is 400 equals C times e to the K times 0. Notice this right here is e to the 0, and then that e to the 0 is just 1. So this guy is 1, which tells me that C is equal to 400. So maybe I'll scroll down a little bit. Alright, so I've got that A of t equals 400 e to the kt. Now, I'm going to use the second little circled thing here. It tells me that at 30 minutes, I get I get 300 gallons in it. So it tells me that A of 30 equals, what is it, 300. Okay, so I'm going to scroll down here a little bit. And what I can do is use those to figure out the value of K. So I get 300 equals 400 e to the K times T. Divide by 400, or K times, boink boink, K times 30, because that's the time. That guy goes in there. So I can divide by 400, I get 3 over 4 equals e to the 30k. From here, I can ln and then divide by 30. So I get k equals ln of 3 over 4 divided by 30, which gives me, what do I get? Something approximately equal to negative 0.00959. So I'm going to come back up top. Maybe not. There, I made it a little bit bigger so you can see everything that we've done so far. So it asks me right here, what's the value at, how much is there at 45 minutes? So I'm just going to use A of t equal to 400 e to the, so FYI, I store that in my calculator as the letter K. I do that so I don't get any rounding errors. Because if you even round off by your last of 3 decimal places, then they'll mark you off, and you won't get credit on an FRQ. So I stored it in my calculator so I don't have any errors. So e to the, and when I write this out, I just write K times T. So it's really exactly the same as that right there. But now that I've defined what K is in terms of a number, I can write that and it's good to go. So anyway, so I plugged it in my calculator. I plug in time equal to 45 minutes. And I get A of 45 equals 259.808. And I should give units, it's gallons. Okay, so that's the answer for part A. You should show all this calculus that gets us to that answer. It's one thing I'm looking for you to do. So, let's move over to B. B asks what's the average amount in the tank from t equals 0 to t equals 60. So I'm going to zoom this a little bit. So here we go. I wrote down what A of t is because we're going to use it. That K value is whatever is stored in my calculator. So it asks for the average amount of water from t equals 0 to t equals 60. So first off, you should notice it's not asking for average slope. What it's doing is asking for average value of the A of t. So we use the average value theorem. That is 1 over the width of the interval. So that's 60 minus 0, which is 60, times the integral from 0 to 60. So if this was 90 minutes, then we would have a 90 right here and a 90 right here. Say it was from 20 to 60 minutes, then this would be a 20. That would still be a 60, and this would be 40. Anyway, so of A of t dt. So all I do here is plug this in. I use fn int in my calculator if you're using a TI. Remember on the AP, if you write 1 over 60 times fn int of whatever, they're not going to take that for credit. You need to actually show what the calculus is that you're using your calculator to do. So that equals, and you could write, if you want, use my calculator, use fn int on my calculator, but it's not really going to get us any points. It can't hurt when you're doing it for me. Equals, so I just plug that into my calculator. I do 1 over 60 times fn int. I'm showing this so you can see what we're doing, not because would get us any points on an AP test. And what I like to do is plug in this equation for y1. So y1, comma, I'm doing it with x's, not with t's. I'm doing it with x's because that's what I have in my calculator, comma 0, comma 60. Oops. So I do 1 over 60 times that, and that gives me 304.155 gallons. And I will zoom out so you can see the entire problem. Oh, so close. There you go. That's the whole thing.